All right, this is our walkthrough of worksheet number 7, molecular formulas, and this is the last one in our chapter. So let's go ahead and get started with this. This type of problem is very, very similar to figuring out the empirical formula. You've got percents, but then the last step is just to find out how much bigger your molecular formula is than your empirical formula. So let's walk through this first one. Again, we're going to go percent to mass. So this is going to be 92.42 grams of carbon. Throw it over 1. And the next one is 7.76 grams percent to mass of hydrogen. Putting it over 1. Now we need to do the mass to moles. So we got grams on the top, we'll need grams on the bottom, and we'll need grams on the bottom here. Carbon weighs, if you look at your periodic table, 12.01 in 1 mole of carbon. And hydrogen is 1.01 grams in 1 mole of hydrogen. So remember, we're going to write our answer up a little bit higher because we're going to be still dividing it. So I'm going to pause this. So after doing my calculations, I get 7.695 moles of carbon and 7.683 moles of hydrogen. So now I'm going to look for my smallest one, which is the 7.83, and divide it. This, of course, is going to equal 1. When I divide the top one, 7.695 divided by 7.683. This equals 1.00 and then some more numbers, which is basically equal to 1. So I know my empirical formula is going to be C1H1, or you could just say CH. Now, I was given the molar mass of 78.12. So the next thing I need to do is to figure out what is the mass of the empirical formula. So I'm going to take carbon and hydrogen, because it's a 1-to-1 ratio, and then add them together to find out what is my mass for the empirical formula. 13.02. So the next thing I need to do is just find out how many times 13.2 goes into 78.12. So in this case, I'm going to take my 78, my known, and divide it by my empirical formula. And that equals 6. So I'm going to multiply each of these by 6. So it would be C6H6 will be my final molecular formula for this compound. The empirical formula is 6 times smaller than what the molar mass I was given. So you know it must be a multiple of 6. Let's go ahead and try question number 2. Or sorry, number 3. Again, percent to mass. And that's of phosphorus. And then I've got 56.36 grams of oxygen. Putting that over 1, so percent to mass. Now I need to go mass to moles. So I need to know what is the weight of a mole of phosphorus. And I look on my periodic table and I see that it's 30.97. grams in 1 mole of phosphorus. For oxygen, 16.00 grams in 1 mole of oxygen. Going to go ahead and pause this and calculate it out. So there's my calculations, and now I'm going to divide by the smallest. And this works out to be about 2.5, which means it's not close enough. I can't just round that up to 3. I've got to multiply this by something so that I get a whole number. Well, if I multiply this by 2, that gives me 5. And if I've multiplied that one by 2, I need to multiply this one by 2, so 2. So my ratio is going to be P2O5 for my empirical formula. The next step is I need to find out what is the weight of P2O5. Phosphorus, the weight of phosphorus, we've already figured out, is 30.97, but I'm going to have 5 of them. Oxygen, oops, I'm sorry, I made a mistake there. That's not 5, that's 2. We have 2 of the phosphorus, so it's going to be multiplied by 2. Oxygen is 16.00, and we have 5 of those. And now we'll calculate these and see what the weight of each of these are. So my grams per mole for my empirical formula is 141.94 grams. Well, then what I know I have is I have a compound that has a molar mass of 283.88 grams. So I need to find out how many times this will go into 283. Divided by my empirical formula. And this equals 2. So I'm going to need to multiply my empirical formula by 2. So that means my final answer will be P4O10 for the final answer for this problem. Let's go ahead and work on the next. All right, so now I'm going to do the answer for number 5, if I can get this to move. There it is. Number 5. So, same thing we've been doing. I'm going to do percent to mass. So, 34.31 grams of sodium. Oops, let's do the correct symbol for sodium. And then I've got, put that over 1. I've got 17.97%, 93. Turn that into grams of carbon. The next one is 47.76% to mass, so grams of oxygen. And then I've got a molar mass that I need to find, which is 134, but we don't need that yet. So percent to mass I've done. Now we need mass to moles. So sodium, I need to look that up on my periodic table and find out that sodium has a weight of 22.99 grams per 1 mole. Carbon has a weight of 12.01 grams in 1 mole of carbon. And good old oxygen there we go. Now we're going to calculate these out and find out how many moles we have of each. All right, so I'm going to go through and I'm going to look to see what is my smallest number. Well, that's going to be this one right here, so I'm going to divide everything by which is going to come out to 1. This is going to come out equal to 1. And this one is going to come out equal to 2. So my empirical formula is going to be S1, C1, O2. I need to figure out what is the weight of my empirical formula. So I need to do S, C, O. Sulfur was 22.99, and I only had 1 of them. Carbon is 12.01, and again I only had 1. Oxygen is 16, and I had 2 of them, which means my total is going to be 67 grams per mole. Now I need to find out how many times my empirical formula goes into the molar mass. So 134 divided by equals 2. So the final formula will be S2C2O4. And there's your final answer. The answers for the even numbered problems. Number 2, the answer is S2O8. Number 4, the answer is C4H10O6N2. And that's the answer for those two problems.